Hey guys, welcome back to the 440 project. I've got some extra time today, so we're going to do a kind of a bonus video and cover some details about camshaft timing, some fundamentals of engine operation, and the cam card and all that before we get into putting the degree wheel on. I did paint the oil pump here, got that thing all set, and yeah, next step on assembly is going to be putting on the timing set and the degree wheel and making sure our cam has proper timing. But before we do that, we're going to do a quick video on some fundamentals of that cam card, engine timing, and all that. So if you're interested, stick with me. If not, you can jump ahead to the next video. I don't think I'm even going to give this one a number. Like I say, this is just some extra detail because it's important to understand cam timing so that, you know, when you get everything together, you know it's right. And if something isn't right, you understand what's wrong and how to fix it. So we'll go over a few things. First of all, here's a typical cam timing card, okay? There's a lot of different numbers on here. Lobe separation, installed centerline, we got lobe lift, preload for hydraulic lifters, duration numbers, and then intake and exhaust valve opening and closing timing, and some more details on spring pressures. So if you know this stuff, I mean, it's not too difficult to understand. For me, I've got to break it down into little pieces. So we'll go over that, and hopefully you learn something, or it'll make more sense to me when I get into putting the degree wheel, you know, on the engine and thinking about, you know, the timing, what's happening when. All right, well, let's start out with the basics. So the crankshaft has a sprocket on it. This fits on a keyway. As you see, this one can be adjusted. And if that keyway is off by any, maybe a degree or so, the timing's going to be a little bit off on the engine. Or if the cam was ground slightly off, you could also have a problem where your timing isn't exactly where it was meant to be. Or you could make a mistake. You could put this on one tooth off. It's happened before. People install everything, try to get it dot to dot, and then they find out they're off by a tooth. And when you've got, say, I think there's 25 teeth on the crank sprocket, and then the cam has 50, okay? So obviously double, a 4-stroke engine, this crank's gonna go around 2 times, and that's gonna make your cam gear go around once. And if you're off by 1 tooth, well, it's you know, 1 tooth out of 50. Well, 1 over 50 is the same as 2 over 100, so that's 2% error. And on 360 degrees, 2% of that would be, you know, 3.6 times 2, about 7 degrees off. So imagine having a cam that's dialed in perfect, and now it's off by 7 degrees. You know, this could be why some people get engines together and they're just not quite right, and then they're left wondering, I didn't do my cam timing checks, and maybe I'm off by a tooth. So if anything, doing your degree wheel cam timing is going to, you know, prove to yourself that it's done right. Highly recommend doing it. And well, let's get into it a little bit more. All right, so this gear on the cam is turning, you know, your cam shaft, and it has a variety of different lobes. Each lobe has, you know, what they call a base circle, and then the lobe itself, right? I'll just draw them as if they're on the same one since this is in 2-dimension. The exhaust valve basically leads the intake valve. We'll get more into that in a minute. And, you know, this is actuating a lifter, okay? In this case, a hydraulic lifter. That's moving a push rod, okay? The push rod is moving a rocker arm. The rocker arm opens the valve. So this stuff's pretty simple. Your rocker arms have a ratio, say it's 1.5, could be 1.6, 1.65, or 1.7 even. On a Mopar, I think 1.5, 1.6 are very common, 1.5 being stock. This is the basics of, you know, what's going on. As this cam rotates around, it lifts the lifter, it actuates a push rod, it moves the rocker arm opens the valve. All right. Obviously, the crankshaft is hooked up to the connecting rods and pistons. The crankshaft has, rod journals on it, and basically every 90 degrees, you're moving a set of connecting rods. So let me see if I can even draw this on here. Let's call this a connecting rod, something like this, and a piston. Throw one of those in there, right? Okay, real simple, but throw a ring on it for you. There you go. So this thing is swinging around, moving the piston effectively up and down, in its bore. In the meantime, there's a chain on this, and this is spinning around, bringing your exhaust valve and your intake valve in to actuate everything in correct timing. Combustion chamber, not the best drawing, but you get the idea. So you're going to have an intake and exhaust valve in the combustion chamber. What else? Okay, so measurements. The timing card, everything's done at 50 thousandths, as it says right here, tap it, lift. So what you want to think about there is as your camshaft is coming around, I'm going to draw it like this, throw a couple lobes on there. I've exaggerated, they're not that tall. But your lifter here, okay, is going to start to move up. And the second it moves up is not when you start your degree wheel checks, okay? You let the lifter move 50 thousandths, okay? And that's just to have a standard in the industry. Also, when it's closing, after that, lobe moves through and it's coming down and closing, same thing. When it gets to 50 thousandths from full closed, that's where you stop taking your measurement. Again, it's consistency between different cam manufacturers. There's a lot of different types of cams, solid, rollers, hydraulic, and they all start to open these lifters or lift the lifters, maybe a little bit sooner and more aggressive than others. So this is a standard. Also, I think the valves, when they start coming off the seat, they need to be, times 1.5. So probably, let's say 0.75, like maybe 75 thousandths, or, let's say 50 to 80 thousandths open before that flow is really significant, okay? So again, 50 thousandths between the lifter and cam, and that's when you're gonna start taking your measurements. Okay, what else? The degree wheel. Okay, so this is kind of like a clock, okay? So I'm thinking about the crankshaft in degrees, and clocks are in minutes, so then maybe there's 15 minutes, but let's say that 15 is equivalent to 90 degrees, okay? And then at the bottom, this is 180 degrees, and all the way around, that'd be 360 degrees. So it's kind of like reading a clock, except it's in degrees. So 360 degrees, really fine increments, that's like, 6 times more than the resolution of a clock. So let's forget about the clock reference, but it's kind of a good one, because as you're going through this and looking at your timing card, there's going to be a lot of different letters, and you got to know what they mean. So this is top center, or what people will call, top dead center. This is bottom center, or bottom dead center, okay? And then you're going to see A's and B's, okay? And an A is obviously after, okay? And a B means before, okay? So this is just like on a clock. Sometimes you say it's, 10 to 12, or 10 minutes before 12. Sometimes you say it's 10 after 12. So again, relative to top dead center, or top center of the number 1 piston, we are checking the timing, okay? Number 1, well, I guess you guys know where the number 1 is, but on a V8 engine, right, we've got 1, 2, 3, 4, and 1, 2, 3, 4. And actually, this one and this one are sharing on the same journal. So the one that's just a little bit more forward, okay, basically a connecting rod difference, is your number 1, okay? So your number 1 piston, in this case, it's driver's side. we're going to be using that one to get to top dead center, verify we are truly at top dead center so that the rest of our measurements are accurate. And then we're going to start checking our cam timing. Okay? All right. What's next? So understanding a 4-stroke. So yeah, these engines are 4 strokes. And how should I draw this? Let's say we have, we'll draw 4 different cycles here of operation. Okay. 1, 2, 3, 4. Okay, now on either side of that, there's a cycle that's either just finished or another one that's going to happen. So we'll touch on that in a minute, but first let's just go through the different cycles. Okay, so 1, 2, 3, 4. Okay, we have a 4-stroke. And the first one, let me draw my piston in here. Crude piston. Okay. But let's say this thing starts at, top center or top dead center. And your first stroke is going to be an intake stroke. So this piston's going to go down. Obviously, it's at top center. This is rotating around. That piston's going to start to come down. And this is going to be, I'll draw it up here, intake. Okay. So it's going to get to the bottom eventually, and then it's going to want to come back up. So let's draw the piston here on the next cycle. Okay, piston ring. Okay, and connecting rod. So now the rod journal is down at the bottom. It's pulled the piston all the way down. Okay, and this is going to move up. Okay, intake, compression. Okay. All right, so after the compression stroke, this thing's getting up to top dead center. Top center, if you will. Sorry, this is a little redundant to keep drawing this, but stick with me. Intake compression. Okay, here's where your spark's going to occur, your power stroke, okay? So now the piston's going to push back down, okay? There's a spark that occurs. There's a flame that occurs, right? And that explosion is what's driving it down. So, this is the key. This is what we live for on an internal combustion engine, power. This is what's twisting the crank, and that in conjunction with all the other 8 cylinders are what's, turning the transmission, which is turning the drive shaft and the rear end and making those tires go. Okay, so that's your power stroke. Okay, then eventually your piston gets down to the bottom. Okay, and again, this has gone around 2 times, as you could imagine, and it needs to exhaust. So now we have to go up and exhaust. All right. So there you go. 1, 2, 3, 4, 4 strokes. Intake valves opening. In the simple sense, when this goes down, you could think that's when my intake valve opens. Compression, if things were, really simplified, it would be closed. On the power stroke, it would still be closed. And then the exhaust stroke, the exhaust valve opens. So that's in a very simplified fashion. But now what gets complicated is that those valves are actually open in the prior cycle and hanging into the next cycle. And that's where we get into some of the, the voodoo of these cam cards and trying to understand it. All right, so what happened right before this intake stroke was an exhaust stroke, okay? And this is kind of key because this is where that overlap is going to occur. So let's throw that in here. So this is the exhaust stroke. That piston's going to be heading back up. And you know what? Over here, after this exhaust is an intake stroke. Okay, and we could draw it over here just as well. But 1, 2, 3, 4. So this is a number 4 getting done. Okay, that's the basics of it. And now what we'll want to do is get into, understanding, I guess, this cam card a little bit more. Okay, well, let's talk about the different valves here. Let's do the exhaust first, okay, and then we'll get into the intake. Well, I don't know that it matters, but okay, so the exhaust valve. The exhaust valve is open 54.5 degrees B bottom center, before bottom center. Okay, so if you think about this, from the crankshaft perspective, okay? I should have left myself a little bit more room here. But let's think about the crankshaft, okay? That 360 degrees, and it's opening 54.5 before bottom center. So let's say here's probably 45 degrees, and right in here we'll call that 54. So this distance here that it's traveling is 54.5 degrees before bottom center, okay? Obviously that exhaust valve is going to stay open all the way to top center, right? And it actually closes 10.5 after top center. Well, top center's here, so that exhaust valve, right, is actually hanging open 10.5 degrees, 10.5 right here, past top center. So this is where we're kind of getting this mix of the different strokes, right? It started opening early, okay, which is basically on the power stroke. So on the way down on this power stroke, before it's reached the bottom, actually a long ways before it's reached the bottom, that valve starts to open. So that exhaust valve is open quite a bit before that power stroke even reaches the bottom. There's like a balance that has to go on. These cam designers or engine designers, have to, I guess balance when you're taking the benefit of the power of that explosion, but not fighting the pumping losses of when this thing's going to be coming back up on the exhaust stroke. So you got to start getting that exhaust valve open early, so you've got a lot of flow and you can get all those spent gases out of the engine, in the amount of time. And you think, well, there's a lot of time. Well, no, there's not. Fractions of a second. Think about an engine just running at idle and then try to go 10 times that, up to like, say, from 600 RPM to 6,000 RPM. I mean, there's very little time available. That's actually a fun thing to think about. Maybe we'll cover that later. But let's continue on the cam card and understanding this. So the exhaust valve, right, we could add these numbers up. So you've got 54.5, right? You've got your 180 over here, okay, and 10.5. Okay, so what's that? 54.5 plus the 180 plus 10.5. Okay, 245 degrees. Okay, so what does it say here? 245 degrees for the exhaust. So that's the duration that exhaust valve is hanging open. Again, starting measurement at 50 thousandths and then ending at 50 thousandths from when it's fully closed and back on the base circle of the cam. Okay, let's do the intake. Okay, so the intake is going to open 14 degrees before top center. Okay, so on this intake stroke, right, 14 degrees before, well, in relative and timing, we're starting here at the top. So it's really opening in the prior cycle. But let's just draw it here, right? So this was the exhaust and the intake, 14 degrees. Okay, so this is 14 degrees before top center, Okay, so that's when my intake is opening, right? And this was exhaust closing. I'll use abbreviations. Okay, and it's going to continue, right? 180 degrees. Okay, it's going to close 38 degrees after bottom center. Okay, so we basically finished this cycle and we're into the next one, the compression, 38 degrees after bottom center. Okay, so 38, let's say that's 45, if that's 90, 38 right around in here, okay? So 38 degrees, excuse my sloppy writing, after bottom center is when that's going to close. So we can add all these up, okay? So let's do our intake calculation. Well, we'll just do it over here. So we had 14 degrees, we've got the 180, and we have 38. Okay, what does that add up to? I should be able to do this in my head, but 14 plus 180 plus 38, 232 degrees. Okay, yeah, 232 degrees is the intake. Okay, what was the exhaust over here? We had 245, didn't we? Okay, so there's the duration of exhaust and intake. All right, so that's making good sense. We know when these events are going to occur. When we get to the engine and do the timing wheel, we'll be able to break that down and understand it well. Lift, we've basically covered that. You know, the actual cam number is only 0.345. So, you know, this distance off base circle, right, is only 0.345. That's not even 3/8 of an inch. So you're not talking about much, but it's multiplied by the rocker arm ratio to give you the total valve lift. All right, so we got that. Let's do installed center line. Okay, so center line. Now we're talking about the intake lobe. So let's talk about this intake and where the center line is. So we know that that thing started 14 degrees before top center. It went 180 and then even 38 here past bottom center. So our total was 232. So half of that, divide by 2, is 116. So we're trying to get, you know, to the center line. I guess this was my intake and this was my exhaust lobe as I was drawing it. So we're trying to get to the center line of it. So we need the halfway point, 116 degrees. Okay, well, we can't just start here because it was open 14 degrees earlier. So otherwise we would just start here and come down and go to 116. But let's start with 116 degrees minus the 14, okay? And we're left with 102. So we have to go from this point, 102 degrees, right? So let's say 90's there, okay? Right about there, right? Okay. So the distance from top center to the center line of the cam lobe was 102. Or from where it started, right? It was 116, which was half of the 232. So that's how you find the center line of that intake lobe. That's what they mean by that. Okay, lobe separation. All right, so this one's a little bit more tricky, but we got to find the separation between the exhaust and the intake lobes. Okay, so the exhaust lobe's coming first, then the intake lobe comes around, and separation is basically this distance here in degrees divided by 2. Okay, so we'll have to cut it in half. All right, so let's figure that out. So where is the center of the exhaust valve? All right, so the exhaust valve was open 245 degrees, right, 245. And let me divide that by 2, 122 and a half. All right, so starting where this thing opened, we got to go around 122 and a half. Okay. Should have left a little bit more clean paper. Sorry, guys. 122.5. So let's subtract 54.5, 68 degrees from here. Okay. So 68 degrees from bottom center is the center of that exhaust lobe, the peak of the exhaust. Okay, so 68. How far are we from top center? Let's think about timing again. We got 90 degrees here, and we have to go another, 22 degrees before we would hit this 90. So we're 90 plus the 22, or mathematically we could say 90 minus 68 is 22. That's what's left here, plus 90. Okay, that's 112 degrees relative till we get to here. So let's write that number down, and we know that that's the measurement from here to the center point of the exhaust. Okay, now let's figure out, well, the intake from here we know is 102 degrees. So yeah, 102 degrees down is the intake. So 102 plus the 112, okay, 102 plus 112, well, we can do that one in our head, is 214 degrees. And like I said, we got to divide that by 2. We got to cut it in half, okay? and you're left with 107. Divide by 2, right? 107. Okay, cam card says lobe separation is 107, so bingo. Okay, so we understand all the fundamentals of the intake and exhaust lobe. You know, maybe to draw it better, let me try to do this over here. Draw a lobe there, draw a lobe there. Okay, your exhaust valve, think of it as leading here, and then you go into your intake valve, moving next, okay? All right, and we figured out how many degrees happen between the center of that exhaust and the center of the intake, okay? And it was 214 degrees. And again, this measurement called lobe separation, I don't know why they don't just call it 214, but they cut it in half and they call it 107, okay? So there you go. All right, what else on here don't we understand? Preload. Okay, well, preload, this is how much preload you're putting on your lifter, in this case, a hydraulic lifter. If you had a solid lifter cam, you'd have actually a little bit of clearance or lash. But these things have like springs or plungers inside them, right? And oil. And you need to compress this just a little bit. It depends whether you have iron heads, whether you have aluminum heads, whether you have aluminum block and aluminum heads, and there's some other guidelines that come in the installation instructions with your cam, I'm sure. But this is a good generic number here, 80 to 95 thousandths preload. All right. So when are you going to set that? Well, you want to be on the base circle of the cam. So if I were to illustrate a lifter here, okay, and then my cam lobe, all right, and let's just draw, there's only one of these on each lifter, of course, but I like to think about intake and exhaust together as I, rationalize this in my head. But you want to be on the base circle of the cam, meaning where there's no lobe lift at all, all right? Now, a V8 engine, firing order typically, at least I know on a Mopar, 1843-6572. So 1843-6572. That's the firing order of a V8. So knowing that, on either side of this, right, it starts over again, 1, 8, ... 4, 3, 6, 5, 7, 2. And then before this, right, I'll draw a line here. It's basically just finished number 2. So you want to get, again, simplified way is when you're adjusting the valves on the number 1 cylinder, you want to make sure you're on the base circle of the cam. So you would think you would, get your cam rotated around so that this thing's on the base circle on number 1, but at top center on your compression stroke, right here, you've already finished actuating your intake valve. You've closed the valves and compressed it. You got your power and you've got your exhaust stroke. So your exhaust valve's primarily moving here, right? Your intake valve's primarily moving here. So if you can get her to top center, that's when you want to adjust your lifters or your push rod preload. So you got to be on the base circle. One confusing thing is sometimes, to get it here, you can think about this, right? Both valves are closed. You could take your spark plug out. You could put your finger on the hole. As this is coming up, it's going to blow your finger out. So you know that the valves were closed because it's putting the pressure of compression there. And that's when you'd want to do it. And the reason I went at all that is because sometimes they tell you to not adjust number 1 when you get number 1 at top dead center. And people scratch their head like, okay, well, why would they not tell me to do that? Why are they referencing number 8 or number 2? Well, it's kind of a safety thing. So if you think about it, 2, the next one coming through, okay, the next thing that's going to happen on 1, right, is the exhaust valve is going to actuate. Well, the next one coming through is 2, so that one is nowhere near the intake stroke, and 8's nowhere near the exhaust. Let me see if I'm explaining that well. So 8 just got done. So it's further along in the timing segment, if you will. number one, when you're here, the next thing that's going to happen, and not even only 2/3 of the way down, this is when the exhaust valve is going to open on number one. So just to be safe, they say, well, go check number 8, okay? Because 1, 8, 4, 3, 6, 5, 7, 2. So, 8's coming up next. So that's the next one that's going to happen. And it's nowhere near the exhaust stroke. See, it's good to think about this stuff. So 8's the next one in the firing order. It's 90 degrees behind number 1. So it's safe to check the exhaust valve on 8 when your 1 is at top dead center. And then it's safe to check your intake valve on 2. So 2 just got done. 2 is certainly in its exhaust stroke. So it's really safe to check the intake, because the intake just got, done on 1, but it's been done for a while on 2. So that's why sometimes they don't tell you to, get it to top dead center on your number 1 piston and then go check, your lifters. They're telling you to check, the one that just got done or the one that's coming next. So that's that. It's really not worth, I guess, worrying about too much. But if you want to be super safe, of course, always follow the recommendations of your cam manufacturer. But I've seen that both ways. Okay, I think we've covered basically everything. This is about spring pressures. That gets into your cylinder heads. And, basically you don't want to have not enough spring pressure because when your engine's spinning really fast, you might have a problem with load of valve. If you have too much spring pressure, well, especially on initial startup, you don't want to wipe out a camshaft. So you want to have the right, valve springs for the type of setup you're using. More racy applications obviously have stronger springs, springs that can, open more, not bottom out, things like that. All right, well, in a nutshell, I think that's what we wanted to cover. Hopefully that made some sense. I'm not sure if that camera was perfectly aimed during the whole thing. So let me just kind of scan over this real quick. Maybe my arm was in the way on some of it. I was basically walking you through the calculations, so hopefully you could follow along. This over here, maybe I was blocking that. I apologize if I was. All right. Well, we'll get back on the engine installation stuff. We'll get the timing set put on. We'll get this degree wheel put on, and we'll start checking everything and get to the next step soon. See ya.